Though I'm the same way. I don't tend to correct people if they say Julie. All right, I will go ahead and get the ball rolling as more people join the room. Hi, everyone. I'm Julia, a bookseller at Politics and Prose, and I'd like to welcome you to PNP Live, bringing you the new books you crave and the authors you love. At any point during the discussion, you can click the link in the chat to purchase Sean B. Carroll's A Series of Fortunate Events, Chance and the Making of the Planet, Life, and You, directly from Politics and Prose. We encourage you to engage with the discussion by utilizing the Q&A feature found at the bottom of your screen. We'll try to get to everyone's questions, so we apologize in advance if we don't have time for yours this afternoon. Before we begin, we want to sincerely thank you for being with us today. We're so thankful to our family of loyal customers who keep our business and our spirits afloat. It's my pleasure to introduce our speakers. In his newest book, acclaimed writer and biologist Sean B. Carroll asks, why is the world the way it is? How did we get here? Does everything happen for a reason, or are some things left to chance? Philosophers and theologians have pondered these questions for millennia, but startling scientific discoveries over the past half century are revealing that we live in a world driven by chance. A series of fortunate events tells the story of the awesome power of chance and how it is the surprising source of all the beauty and diversity in the living world. Like every other species, we humans are here by accident, but it is shocking just how many things, any of which might never have occurred, had to happen in certain ways for any of us to exist. From the extremely improbable asteroid impact to the wild gyrations of the Ice Age to invisible accidents in our parents' gonads, we are all here through an astonishing series of fortunate events. And chance continues to reign every day over the razor-thin line between our life and death. Moderating today's discussion is NPR science correspondent Joe Palca. Since joining NPR in 1992, Palca has covered a range of science topics, everything from biomedical research to astronomy. He is currently focused on the eponymous series, Joe's Big Idea. Stories in the series explore the minds and motivations of scientists and inventors. Palca is also the founder of NPR SciCommers, a science communication collective. On behalf of Politics and Prose, please join me in welcoming Joe Palca and Sean B. Carroll.
Is that us?
That's us, Joe.
Hi, Sean. How are you doing today?
Good, Joe. I'm doing well. How about you?
Well, I wish I were sitting next to you in front of a warm bookstore, having just walked through what's nice, bracing, cool fall day here in Washington, but instead we're looking at each other through little boxes.
Yeah, truth be told, we only live about 4 miles away from each other, and Politics and Prose has been one of our meetups, but
That's right.
Not this year.
No, it's too bad. Well, so yeah, and I really did enjoy Julia's introduction, and the book is delightful. But maybe you can tell everyone why you chose to write this book.
I chose to write this book because I think chance is an underappreciated fact of life, and I really mean of biological life. We can think about chance in other ways, but I think it's just gotten kind of the short shrift in scholarly discussions, philosophical discussions even. And as times has gone by, scientists keep discovering major events that we didn't, first of all, suspect whatsoever, and then realize that had they not happened, you and I would not be having this conversation. And so I think that the power of chance comes from understanding individual events that either shaped our existence collectively or ourselves as individuals. And the approach to the book is to sort of balance, it's kind of like a big what if story. And I sort of balance individual stories of what if, characters that we may know or intriguing people from human stories with these bigger picture stories about our planet or about life on Earth.
Right. So You talk about these really unlikely events that happen and how much of an impact they had. I mean, you talk, well, there's one that's central to the book. Why don't you talk about that?
Well, I chose to start the book with the asteroid, and actually I juxtaposed that story with a human story of a very close call. And this happens to be the story of Seth MacFarlane, the well-known creator and executive producer of Family Guy and of The Orville and of movies like Ted. And Seth was one of those people who, were it not for being late to the airport on the morning of September 11th, he would have been on flight 11 that hit one of the towers. And you know, what a difference 30 minutes can make in an individual life. Well, I juxtapose that against the story of the asteroid, because while most of us have heard the headline about the asteroid that took out the dinosaurs, that headline doesn't really do the story justice, because this was really a huge reset of life on Earth. And it was an incredibly rare event. It's the only asteroid impact of its size we know about for the last 500 million years. And as it turns out, so it hit the Yucatan Peninsula, streaked across the sky, across the atmosphere in maybe about a second, hit at 50,000 miles an hour. And while it's a 6-mile wide rock, and that doesn't seem very big relative to the Earth, we now understand that moving at that speed, it blasted an enormous amount of material out of a huge 20-mile deep, 100-mile wide crater. And as that material was vaporized and shot into a plume and orbited the Earth, circulated the Earth, you know, blocking out the sunlight, shutting down photosynthesis, you know, really changing life in the oceans and on land forever. And at the time, the dinosaurs were the dominant animals, both in the land and the sea and in the skies. But mammals, our group that had been around for about 100 million years, were kind of small, you know, not kind of nondescript stuff. Well, it's very clear from the fossil record that this asteroid impact wiped out all the big stuff, and some of the things that survived were these small mammals, and those small mammals started evolving to be much larger very quickly. We can now see from the fossil record in places like Colorado what happened right after that. And so we understand that really it was that sweeping away of the dominant life forms, the dinosaurs, that made room for mammals and eventually primates and eventually us. So I start the book with that story because that's really kind of the mother of all accidents. And you can go further back in time and you can think about the origin of the Earth, or you could go all that, but I just think that's really proximate to us. That's the world we know. We live in the age of mammals, and the age of mammals was really brought in by that asteroid.
But do you think people have okay, first of all, it's sort of, the book is also about whether chance as a concept is easy or difficult for people to accept. And, you know, saying, well, our existence depends on an asteroid hitting the Earth 65 million years ago, because otherwise we wouldn't be talking today. We'd be doing something else, or we wouldn't be doing anything.
We wouldn't be doing anything.
But really the question is, I mean, the two things are going on there. One is this incredibly rare event occurred. The second is this incredibly rare event had fantastic implications. And I wonder if people sometimes have trouble putting those two things together.
Yeah, well, I think it sort of shatters people's ideas of sort of, that life is on some kind of plan, right? I think George Garrett Simpson, a paleontologist, said, if that's a plan, it's a really bad one. Because nothing about those species that survived had really, pre-adapted them for an asteroid. The asteroid is this, this rock was probably circulating the solar system for 4 billion years and enters the Earth's atmosphere. And here's that close call factor, which I didn't complete in the story, which is, had it entered 30 minutes sooner, it hits the Atlantic. 30 minutes later, it hits the Pacific. And we now think that the rocks that it hit really mattered, and that a very small proportion of the surface of the Earth has the right mixture of rocks that when vaporized would cause a mass extinction. So that asteroid might well have hit the Atlantic or the Pacific and not caused a mass extinction. So not only is it an asteroid impact is rare, but where it hit on the Earth matters, and it may have been just a matter of minutes one way or the other as to whether or not those conditions happen. So yeah, you have this profound event that almost didn't happen. and it's, you know, profound for us in the world that we know. And I think that is hard to get around, but I think that's where, to use, you know, your brand, this is a big idea. That's why I think makes chance a big idea, that 50 years ago, you know, when the asteroid theory was first proposed, you know, the scientists got a terrible reception. And you know, very kind of mean almost, because the idea that life would be changed in an instant was so contrary to the idea of sort of gradual change on Earth. They had a hard time until the crater was found 11 years later. So even the scientific community wasn't comfortable with this idea, let alone how that lands on the general public. And then, you know, since then we've discovered other things that it's sort of one of the, you know, those who would have thunk it kind of things that tell us, you know, how the world became the way it is and how easily it could be a different way.
You know, it's so funny. The questions that pop into my mind anyway at this point, I think are different than most people, because I've thought about this concept quite a lot. You've introduced it before in books, or we've talked about it, I think. And I'm familiar with the idea that this rare event could happen. And so my questions would tend to go in one set of directions, but I think anybody who hears this says two things that you probably don't have answers to. One is, what would have happened if that didn't take place? What would the Earth look like? And two, can it happen again?
Yeah.
And those are, I think that's the sort of the scientific versus the popular way of hearing what you've just described.
Yeah.
So scientifically, there's all sorts of questions that follow from what you've just said.
Yeah.
But in a human sense, like, what's the first thing you want to know? Well, could we all die again? Are we in the middle of another extinction event?
Yeah. Well, those are great questions. In fact, until this was discovered, you know, nobody was really thinking about asteroids. And then not long after it, you may remember the comet impact with Jupiter. It was called Shoemaker-Levy, is that right?
Shoemaker-Levy 9, yep.
And we watched it in real time. If folks can go back or look this up on the web and see these pictures, it was amazing to be sitting on Earth and watching the very type of event that, had it happened on Earth, we would have been watching probably the end of civilization as we know it. I mean, that was a pretty big comet hitting a pretty big planet. Yes.
Yeah.
Yeah.
It was a much bigger planet.
Yeah. But the fact that you could even imagine that we could actually see this happen in our own solar system in real time, you know, because we talk about the age of the solar system and the vast amount of time, and often we're looking at, you know, back at events that were a long time ago. So to see that comet happen, I think that just, you know, I think that brought it home to a lot of people that we do live in a world and, you know, in a solar system, in a universe where these kinds of things happen. So of course they could happen again. Now the asteroid that size, to our knowledge, hasn't hit the Earth or the Moon in at least 500 million years. But, you know, the Chesapeake Bay was Chesapeake Bay was made by an asteroid impact probably 30 million years ago or so. So there's been 10 or 12 pretty sizable asteroid impacts in the last 66 million years. We don't know of global effects on species, but we would certainly expect pretty dramatic regional effects. So, you know, I don't know, average that out, say, hopefully if one doesn't hit more than every 5 million years, we got time to get a little work done here.
Well, I have to tell you a funny story. Again, just because not because it's related to your book, but because it was an asteroid question. I went to New York on a Friday, or actually on a Friday morning, to host Science Friday a number of years ago. And you may remember that there was TWA Flight 1 or Flight 11 or some number like that exploded after it took off. And it turns out, and I'll jump to the end of the story, that there was a spark. The plane was a 747. It wasn't very heavily loaded. And after it took off, a spark in the mostly empty gas tank set off the fumes, and the thing kind of blew up. But nobody knew that at that particular moment. And I was told, you know, whatever you were going to do on Science Friday, don't do that. Talk about this accident. And so people called in with questions. And there's only one question that I remembered, which was, is it possible that an asteroid hit the plane as it was taking off? And again, this rare but possible question popped up, because I wanted to say that's the most ridiculous thing I've ever heard. but you know, that's not a nice thing to say to the audience when you're hosting a show. But it just made me think again that I said, it is a possibility, but it's not, I think, the one that people are focusing on for the explanation right now.
Yeah, yeah. You can imagine with like what, probably 4,000 or 5,000 planes in the air at any given time. That, I mean, you have to work that out as what the chances are. But you know, we know because when something's of some size enters the Earth's atmosphere, and enough to make a boom, enough to rattle windows or something like that, you know, it often makes news, right? Somebody sees a bright object, or you know, it was in the Russia not too long. Well, what was that? Maybe 6-8 years ago, where you could see it on all the dashboard cameras, and it blew out windows, and a lot of people got hurt. You know, and anyone who likes meteorites, you know, we find them, of course, all over the surface of the planet. And you know, there's stories in science museums of, you know, meteorites going through people's cars, or you know, houses and things like that. So it's possible a chunk of something could be large enough to take down a plane, but it's not the first hypothesis I would work on.
So the other thing that's really cool about the book is it talks about these rare events, well, these chance events, one of which is happily fairly rare, once in 65 million years, and the other are happening every moment, essentially, inside our bodies. And I think that's a nice contrast. But talk about the chance events that are happening all the time.
Yeah, well, I play a little pop quiz in the book about just that everybody can play along. You think, okay, how many unique children, genetically unique children, could our parents have had? So one couple, how many unique children could they have, genetically unique? Now, they each are contributing 23 chromosomes to that child. So how many? And it turns out it's over 70 trillion. So what that means is that no two fertilized human eggs will ever be the same, because the number of genetic possibilities is so huge that you know you'll never repeat the same combination. And in fact, there are additional genetic mechanisms that absolutely ensure that the real number of genetically possible children is even higher than that, because of some ways that the genetic deck gets shuffled, and some mechanisms like mutation. So we truly are each unique, and maybe we take some pride or comfort in that. I don't know what it might be. But at the same time, you know, we were each from 1 out of 100 million sperm or so that were making a swim. And we just happened to be the one that made it. And so there, you know, there are a lot of possible siblings that we'll never have. You know, after I was born at 10 pounds, 5 ounces, my mom stopped at 4. So, you know, she was well short of the 70 trillion mark. But as you mentioned, things going on in our bodies all the time, in every cell in our body that's dividing as it copies its DNA, we know that new mutations arise every time you copy this 6 billion letters of DNA in our cells. So, and that mutation it's a built-in feature essentially of DNA. There's nothing you can do to stop that fact. And most of the time that doesn't matter much, but certainly, and in one of the not so cheery chapters in the book, I deal with the phenomenon of cancer, because that's certainly the underlying root of cancer. So that's where chance plays a role, you know, throughout our lives, and it's good for us to know about that, because there are things we can do that increase our chances of getting mutations, and therefore there's some things we want to do to prevent that.
You know, I also often think about the flip side, which is we've got these 7 trillion combinations, and we've got these 23 genes. And what amazes me, and I guess this is a developmental question as much as anything, is that it works most of the time. I mean, we don't have an arm sticking out of our head, or, you know, 2 ears on our left elbow or something like that.
Yeah. It is amazing. And as a developmental biologist, I'm still amazed. I've looked at millions and millions of fruit flies and fruit fly embryos, and you get an appreciation when you look at that many, just how often it goes right. And of course, sometimes it does not go right. And we understand for humans some of those risks that increase with, for example, both father's age and mother's age. But it is amazing how many things go right in the making of humans and other creatures. And you know, hopefully that's some testament to what hundreds of millions of years of evolution gets right and continues to get right.
Well, so you just mentioned the notion of shuffling the genetic deck, and I guess as it has consequences for an individual, but it also has consequences for all creatures, great and small. Talk about how genetic variation or random mutation is really essential to life that we see on Earth.
Yeah, so I'll start maybe with the headline, which is, chance is the source of all diversity, all beauty, all novelty in the living world, because the beginning of diversity is this process of mutation. It's changing the existing genetic code that generates variation. And we understand that and I described this in the book, and some of this is actually very recent science, to appreciate that mutation is a feature, not a bug in DNA. It has to do with the chemistry of the bases that impart DNA with its special properties, but that those bases go through little shape shifts. So for example, when the DNA is being copied, if these bases, as they're exposed, they can go into an alternative chemical form, just last 1/1000th of a second. But if the copying machinery goes by at that instant, it can insert the wrong base. And that's the root of mutation. So you only make 20 or 30 mutations in a child that has 3 billion base pairs, right? So that's a great typist. I mean, that's phenomenal accuracy. But the thing is, if you got it 100% right every time, life would never change, right? Everything would be a copy of everything. And so that would be it. So you have this sort of dual impact, which is, mutation is there. If sometimes it does create problems, but it is also the root of all variation. And I think that this is why I especially wrote a book about chance, is I think it's underappreciated that this sort of ticking mechanism that we can't do anything about, that's intrinsic to DNA, is just the diversity generator, on the planet. And as we look around ourselves, I mean, basically we live in a world of mistakes. I love butterflies, giraffes, and all the other mistakes, but they generally, those things only come about through a series of lots of mistakes.
So what's the significance? I guess this goes back to species. You talk about, when are there enough mistakes to make it clear that one organism is now distinct from other organisms? I mean, how many mistakes do you need?
Well, biologists are working on this. It's a great question. It's a current question. In other words, it's not like, we settled that decades ago or something like that. We're just kind of trying to study enough kinds of creatures to sort of take a stab at that. So we can see differences between creatures, but that doesn't make them different species. There's a lot of possibility for interbreeding out there, far more than kind of the textbooks ever said. That the barrier to breeding among very closely related things is generally not that high. But some biologists have estimated that by about 2 million years, there's enough sort of independent ticking of the mutation clock that you have lots of incompatibilities. If you try to then bring those organisms together genetically, their genes don't work well together, and the hybrids are inviable, or they're sterile. And a round number might be a couple million years. So, but that is a lot of just accumulated random variation. So it's also telling you that perhaps a big driving force behind speciation, another source of novelty in the world, right? We count the millions of species on the world, is really just this random buildup of genetic differences that are eventually just too many for those genes to work together. And so that's just telling us that even the generation of species is just essentially driven by this random process.
I'm just wondering, I mean, we talk about species disappearing. Are there species appearing?
I think if we could, it's, full formation of species takes some time, particularly of larger things like plants and animals. At the bacterial scale, I think there's enough mixing of genetic material that we would probably distinguish some of these things as species. But given a little bit of time, and we've seen sort of speciation in real time, a good formation of barriers among some things like flies in apple orchards and sunflowers at the edges of fields and things like that. But you got to run the clock a little bit longer. The building up of these barriers so that if two species are the product of one species splitting into two. So it's a splitting event to get new species. And if they don't, for them to not come back together, there generally has to be either physical separation, like different islands or opposite sides of a river, or genetic barriers. And those genetic barriers take a long time to build up. But we've seen good species form in, over the decades of some creatures, but it's generally a much longer process, so not observed on the human timescale.
I just want to I'm just going to pause for a second to tell everyone that in about another 10 minutes or so, we're going to throw the conversation open to people who want to use the Q&A button at the bottom of the screen and pose questions, because Lord knows somebody knows that I don't ask all the right questions. I don't know about the Lord, but we'll leave that out for now. But yeah, we'd be glad to hear other people who have questions, and I'll read them when we get to that point. Maybe I can just get you to wax eloquent a little bit about what's happening with this virus that we're all focusing on, and how, are we victims of the coronavirus completely by chance? Or is there some driving event, or is there some reason? Why would the coronavirus that's infecting people around the world have emerged and be still extant in such a short space of time?
It's a great question. Well, here are the elements of chance that are pretty clear. So there's huge numbers of viruses circulating in wild animals. And occasionally they escape. Maybe the most famous pandemic that we've experienced is AIDS. AIDS, we understand pretty well that there was a spillover event. That's the term for viruses coming from wildlife into humans, a spillover event in the early 20th century from a virus that infects chimpanzees, for example, called simian immunodeficiency virus. And some mutations happened in that virus several times, as it turned out, that enabled it that when in contact with humans, it could then spread in humans. And that contact could have been, and it was probably happened in West Africa. There's lots of forensics behind this. Could have been, bushmeat would probably be the easiest explanation, just in the butchering of an animal that was infected, and it turns out the virus could get there. And that may well be the source of something like this coronavirus. People have pointed to the wet markets in China. So whether it's, bushmeat or pets, there's evidence that both bats and pangolins may be involved in this story. But what you have is viruses that are just randomly mutating, and viruses are usually present in pretty high numbers in an individual animal. So you're essentially scratching more lottery tickets that you're going to come up with a virus that can jump into humans. And when that happens, it could just burn out, may hit one person and has a mysterious illness and nothing happens. But this is a respiratory virus, and so it was easily transmitted human to human, and away she goes. And so, the accidents there are the random mutations in the virus, the encounter between some wildlife and patient zero, essentially a human, to get it started, and then where it went from human to human. Now, once we knew it was happening, of course, lots of subsequent infection and travel around the world, once we knew better, is, of course, perhaps it's more up to us to tamp this thing down. But the beginnings of it, spillovers and pandemics are really accidents waiting to happen. MERS, SARS, flu, AIDS, Ebola, all of these things.
But if it accidentally popped into existence, why doesn't it accidentally pop out of existence?
Well, the thing about viruses is, these are replicators, and what brought viruses into existence is they're really efficient they have efficient ways of copying themselves. And as they get into new hosts, they make more and more copies. So lots of viruses, I'm sure there are huge numbers of viruses that could be out in the wild right now that if they got a chance at humans, they could jump into us, but there won't be an encounter. And some of those viruses are just transiently there in an individual animal, mutate, but then fade away. So imagine a population of viruses in a given bat. There may be something in there that could infect a human, but that virus is either taken care of by the bad immune system, or that bat dies and never encounters. So there's probably lots of potential out there that never comes to anything, and that those spillover events are, they require a couple of things to sort of go wrong from a human point of view, or go right from the virus point of view.
But still, I wonder, I mean, I guess as I was sitting here thinking, I mean, well, no, it's not purpose, but a virus exists to replicate itself. And as long as nothing stops it from replicating, it'll keep replicating, et cetera, et cetera, et cetera. But we always talk about the virus is mutating so that it can evade the immune system, or HIV, famously, many varieties. How come, again, the one that mutates it, that makes it hard for the immune system to recognize, why aren't there some that mutate that make it hard for the virus to replicate? I guess those just get left behind.
Exactly. There will be mutations because mutations accumulate at random. So mutations in the virus that decrease that virus's ability to replicate, they're washed out of the virus population in the individual right away, or even inside an individual cell. So virus variants are competing with other variants of that virus, and those that are either better at copying themselves or more contagious, more easily transmitted, well, they're going to find hosts more readily. So it's an arms race, and the virus, got a heck of a start on us. Now, you mentioned the immune system. It's real important because we fight these things.
Yeah.
Had the first person, who got this coronavirus, just happened to have, who knows, gone to bed and lived by themselves or something like that, that could have been it. The virus could have that would have snuffed out the virus, and if they didn't pass it on to anybody else, that was it. So who knows how many sort of silent events happen in a given year with almost 8 billion people on the planet and viruses everywhere. But our immune system is we have a great defense mechanism. This virus just is more powerful than some of the viruses we normally encounter at killing us, or at least making us really sick. But most coronavirus patients do survive, and they survive because their own immune systems eventually mount enough of a response to squelch that virus out. So we're at battle with these viruses. Yes, they get into us, but we're the descendants of animals that for 400 million years have had machinery for thwarting these invaders. So, upon exposure, the battle is on. And fortunately for most of us, we'll win the battle, even if we feel sick for 1 week, 2 weeks, 3 weeks, whatever it might be.
Yeah. No, it's well, two things. I want to comment before we open the discussion up. But one of the things, I mean, you give a description of how B cells are capable of recognizing something they've never, or generating antibodies that can recognize something that they've never seen before. Absolutely novel, never been around. And again, it gets to this power of combinations, coming up with many millions, billions, trillions of different versions of something, and only picking the ones that work, and the others just go away.
Right.
But the reason, so that was a great explanation, helped me a lot understanding, and I'll steal it because that's what journalists do when they explain things to people. But the point I want to make, the didactic point, is in telling the story of chance, which is what the book is basically about. You tell it with a lot of, it's not a textbook, and it's not even a explanation. It's a story. It's a story about our lives. It's a story with characters. It's a story with weird things. And I think in terms of scientific communication, which I do some of, what it takes advantage of is this notion that people like a story. I mean,
absolutely.
Yes, there are people who are desperately interested in immunology, and there are textbooks that explain it very well, and there are even popular books that are still explaining immunology very well. But the memorable stories are the ones that you tell, which are, yes, you learn a little bit about immunology, but you're also learning the story of science, how it happens, how people come across things, which I find very compelling. And I know you've thought about it, especially I got to the afterword, as you warned me. So you try very successfully to find stories and communication techniques that engage people so that it's not spinach journalism, which is you should learn this because it's good for you.
Yeah, that doesn't work. That doesn't work. I mean, I think that this is the hardest thing, I think, for the scientific community to adapt to, that, I think we, partly because the way we're trained, maybe it's our kind of our community, is that we sort of think if you just knew what was up here in our heads, that's all we're trying to do is just, move it from here to there. But it's that's just not the way, that's not the packaging that works for our brains. Our brains are wired for narrative. Narrative tells us about cause and effect. It tells us about events through time, a character that we find interesting, or we start to empathize with their motives, or their trials and tribulations. That's, and we crave that all day long, right? I mean, it's why we seek stories in literature, on streamers, on TV, on radio. We want stories. So science is competing with every other type of story in the world. So science has to tell stories, and it has astonishing stories to tell. Oh my gosh, this rock from outer space came and changed life on the planet and made it possible for us to be here. Or inside every cell in your body right now, there are little changes taking place that, if it's in your gonads, help generate the diversity of humanity. If it's elsewhere in your body, might kill you someday. So maybe you want to know about that. So I think that, stories are, they're the vehicle that we have to use in science. And that means with stories, you got all sorts of things. You have humor, you have drama, you can do it with science fiction. You can do it in so many different ways. And so I think that, what I've been trying to stretch as a storyteller over a course of books, and with this one intentionally, was to have a little fun with chance, because we have funny ideas about chance. We have funny ideas about, why good things happen to us, or why bad things don't, or sometimes when bad things happen to us, we really struggle with that. And so we have this very funny relationship with chance. And I want to, I explored some of that in the book as well. And the only way to do that is through story. And if you look at, I bring up Kurt Vonnegut in the book because I was a fan of his as a kid. And I go back to 1959 in The Sirens of Titan, and he's talking about our accidental existence. And I thought that's pretty bold for 1959. And, nobody ran him out of town. Or he probably was run out of town in a few places, but I just don't know those stories. So, and I think it's where scientists can they just have a contribution to the culture and to cultural dialogue, and can connect with just thinking people to talk about things that everybody can, you don't need any technical background to have conversations about these things. I think that's one of the ultimate goals, is to bring people in. Don't make a technical background a prerequisite. Make it accessible. Tell a story.
Well, and I think it helps when someone with your stature as a scientist can say these things, and somebody very deeply versed in the field will say, well, that's not exactly how you do it. And you will have the confidence to say, yes, I know that. For the purposes of this discussion, that's close enough to what's actually happening. Because I think a lot of younger scientists, and that's mostly who I deal with, they get tied up in being exactly right.
Yeah.
And because as a graduate student, you get it wrong, and there's a tendency to pile on and mock.
Yeah.
And so if you're established, they know that nobody's going to ask, oh, does he really understand how DNA works? Yeah, I think we can probably grant that he's got it by now. So if you use an analogy that helps, it doesn't have to be spot on in terms of specifics.
I think also that the judgment you have to make is to sort of be comprehensible without being comprehensive. We're used to, as scientists, being more comprehensive and using all sorts of caveats. And we write for each other. We write in a fairly thick prose. And there's an obligation to be thorough in citing all the relevant work, et cetera, et cetera. But in a trade book like this, there's nothing in the book that's wrong that I'm aware of. It's just I leave some things out because you don't need them to get the gist of it. If you're going to get a wow, if you're going to get something and somebody says, yeah, I hadn't thought about things that way. Well, I got to kind of get to the nub of the story pretty quickly and not drag you all through this, as I said, sort of the prerequisites. And I think the same, Joe, goes for science education. I think science education is going to go through some deep reflections because, we greet students with backbreaking textbooks that are, incomprehensible, joyless encyclopedias, and it turns a lot of people off to science. Whereas I think if a few good stories following sort of the course of discovery and following those journeys is a better way for people to understand the scientific process and include more folks. And so I think we have to get away from our just massive information transfer to more of a storytelling mindset.
Yeah, well, you won't get an argument from me. Let me remind people that there is a Q&A button at the bottom of your screen. If you don't see it, you can just move your mouse down to the bottom and it'll pop up. But I see it on mine, so presumably you do. So let me go to some of the questions that have been coming in. One is from Zachary, and he says, I take a chance there. Everything on Earth is being imperiled by climate change, yet there hasn't been a unified/coordinated response. Let's say we get to a point where there is a global consensus that we are imperiled. Could you envision a UN-type organization that receives resources from the G20 that can serve as a guardian or lifeguard role?
Well, I think we could all join in on this question because it's more of a judgment of not so much scientific knowledge, but of collective will, political will. How do we prioritize resources, et cetera? I think that I'm going to take a little different action on this for a second, angle on this, which is, I don't think first of all, I think our environmental problems are broader than climate change. And I don't mean to say this is a bummer. There's a lot of environmental challenges that are addressable at a more local and regional scale. And we can't wait for a UN organization with support from the G20 to take these actions. So some things we do need to work on a large scale, but there's lots of solutions out there that at least take a bite out of this problem. Oh, Joe's going to love this because he's going to see there's a pun coming that I did not intend, but I'll just give you an example. Plant-based meat. Now I'm not, anyone who knows me knows I like McDonald's, but it's probably not sustainable for the long term. And when you realize the resource tax on the planet for wanting livestock-based meat, the use of water, of land, what that does to the air, the destruction of forests, et cetera. Okay, now we can proselytize, we can kind of go for the moral argument, but here's the other thing. How about this? How about people invent plant-based meat that tastes, cooks, and works in all our favorite dishes, just like the meats we're used to, and has a much lower tax on the planet? How about that? Absolutely a free substitute that has all the properties you want, and you can feel great consuming it. And this is actually the founder of Impossible Foods, is a colleague I'm connected to through my organization. And he left academic science to try to pull this off because he thought it was the most important problem he could work on, a fellow named Pat Brown. And so that's just an example of, that's not waiting for the UN, but that will be a consumer-driven movement with no moral overtones or anything like that, just because people can consume this and feel good that they're doing also sort of the constructive thing. So I'm a little off line of your question. I'd love to see a G20 supported global organization, and UN is doing lots of things with its global environmental work. That's all very constructive, but clearly we can feel that some of the industrialized nations, ours in particular, have been dragging our feet in what's necessary. But there's lots and lots of angles to take here. And I think we have to actually tell those stories so that people can understand what can be done, not to be paralyzed waiting for the huge, global consensus to take enough action.
Okay. Let me go to another question. This one's anonymous, but it's thoughtful. Our universe has just the right physical laws to enable life to exist, or at least our kind of life. Do you think that was an accident, an act of God, or evidence of multiple universes? And I'm gonna put on my bulletproof vest now and wait for you to answer this.
I thought, what a great question for Joe. Again, everyone on this webinar is equally qualified to address this question and to think about it. But since there's a you in there, I guess I'm on the mark. I think that from what I understand about the origin of the universe so far, and of course it's a still evolving, unfolding story, I think that those laws are an accident, and if we believe that there are multiple universes, then We're just, one experiment in the multiverse. So I certainly will just, say right out that I think that life is a property that does evolve a lot in our universe. So most astronomers, and Joe can weigh in on this, most astronomers or biologists I've even talked to about this think that if we could inspect the whole universe, we'd find life in a lot of places, probably sort of small microbial type life, not necessarily, radio correspondence and giraffes, but so it seems to be a property of matter that could happen many times. So, but that's still that's still an idea to be tested. But I think Joe should get a shot at this since he has his bulletproof vest on.
No, I have. Well, so I thought maybe you were going to adjust the question, and you talk about this some in the book. When Jacques Monod wrote this book about chance, he was, pilloried by theologians who said, chance, we're more than an accident. Something has happened here to make this creature that is called us. And it would be, it's I don't know if it's blasphemy, it's sacrilege. I don't know what the right word is to say, otherwise. At least I think there's other kinds of ways to keep religion and this concept of chance in balance so that you can have both. But certainly some felt that it was an affront. Again, I don't find the notion of chance particularly disturbing, but what I do wonder, and this gets to the sort of the question of, we say, okay, all these things that we think are happening randomly because we don't see a pattern in them, or it's very hard to prove that there isn't a pattern, right? Now, just because you can't find a pattern doesn't mean there is one and you haven't found it. But it doesn't mean there's not one and you haven't found it. And what intrigues me is that there may be a different way of looking at the universe that might reveal a pattern that we can't get our heads around yet because nobody's come up with that concept. And I'm thinking about, the speed of light and relativity and this question of, well, gravity works like this. And it's only when you get to certain places that you can find what Newton thought about gravity breaks down. And then you need another explanation. And so random works to explain the world, but at some point it might break down and there may be something else that's explaining the world.
Yeah, I mean, certainly, what looks like random could be things that we haven't discovered, that's for sure. I feel more confident in some of the things that I've talking about in, for example, random mutation, that it's completely unpredictable as to which individual and population will get a mutation. It's completely unpredictable as to what bases will mutate in an individual. And those mutations happen without any regard to the consequences of that mutation. So, and since that is what we understand in terms of the makeup of beings, the code, the genetic code for the making of everything, I feel very confident in saying that at the root of biological diversity is a chance-based mechanism, a really random mechanism. In the universe question, raised by the viewer, my immediate instinct is to say, well, if you want to know whether the laws here are special or anything like that, I want to know what the laws are in another universe. If you want to know if life here is special, I want to know what life is like, on another planet. So unfortunately, we just, we have one universe and, one form of life. So the comparative method would help a lot here if we could compare anything else that's happened in the universe. And hopefully we will develop the technology that makes us able to interrogate certainly life elsewhere. I don't know about interrogating anything outside of our universe, but it's fun to ponder. It's fun to ponder. But, over the decades, I would say that, science has restricted the domains of the unknown over time. And it just discovers phenomena that are, when you get to sort of the nuts and bolts of them, we just know a lot more. And including, Joe, you were talking about human existence. And one of the stories I tell in the book is about the influence of the ice ages on humans and how we got into an ice age. And it's the first ice age in 300 million years. And, I mean, humans are special in lots of ways. Thank goodness. I mean, from Tom Petty to Meryl Streep, but as a species, our big brains look like an adaptation to this very volatile long-term climate cycles that have been going on for the last 2 million years. And that because as tool makers, we could shape our own habitat and we can take the command of fire, et cetera. We just did a lot better than other mammals through this time period. And now, sort of we're using our big brains for some other things, like Zoom chats. So I think we look for the biological root of humanness. I think there's a story there that sort of fits with an accidental origin.
Okay, so we've delved into this very heavy duty topics. They just popped up a question which amuses me, so I'll read it. How often do you get confused with Caltech physicist Sean Carroll?
That's a great question. Well, Sean and I have been conspiring a little bit to increase the confusion. So I was on his podcast last week. It's the first time we've paired up like that. But yes, I will get email for him for sure, and vice versa. I'll have his picture alongside one of my books, at bookstores. So we're getting a kick out of it. I think in terms of the space that we cover, it's very nicely complementary. He has a great sense of humor about all this. And so, I'm trying to think of some way where we can take advantage of this, like, franchise. Maybe more people should just license the name Sean Carroll and just mushroom it out there and see what we can do, so long as you're, pretty responsible with respect to the treatment of science.
Well, I mean, not to rain on your parade, but there's another Joe Palca in Washington who's also a radio guy. So yeah, so go figure. The only thing he does is he spells his name differently, but you wouldn't know it to hear it anyway. Very strange.
Yeah.
Okay, another question. This one from Laura, more in the serious vein. The population of Earth has almost quadrupled since 1900. It was about 2 billion then. Many of the problems we are confronted with today, including virus spillover events, are caused by our exploding demographics. Why is there not more attention placed on this issue, Sean Carroll? And how many billions of Homo sapiens can planet Earth sustain?
That's a great question, Laura. I think that's the question for the 21st century. That's the question that, collectively we're all going to have to address. And really important, that perspective of just how quickly the population has grown. And in that time, we've kind of grown without paying much attention to, where we forested, farmed, fished, whatever, all of our activity we needed to, house and sustain ourselves. And I'm not going to be a huge anti-human critic here. I'm just saying we didn't know necessarily what we were doing to the ability of nature to replenish itself and to sustain us. But it's very clear that this is not sustainable, that ecosystems cannot keep giving us the water and food and fresh air and things like that we need if we treat it this way. But I can say there's so many behavioral changes we can take before worrying. Well, we can still think about population growth, but there's certainly a lot of behavioral changes we can take to make this more sustainable and to restore ecosystems. And the good news is that we are also learning around the world that nature is incredibly resilient, and if given a chance, she can come roaring back on a pretty short time scale. So I hold that hope in one hand, but the reality in the other that the Earth is changing, and it's the question of how fast and in which direction is up to us. And you've underscored it. I don't think there's any number that scientific community would sort of agree on what the Earth can sustain, because if you build in more assumptions, we can probably sustain more people. But we have to manage our resources, so much better. And as we get, as that number increases, the absolute number of humans that are influenced by that poor management, poverty, drought, starvation, civil disorder that results from that, that's going to grow. And I say the absolute number because, among 8 billion people, it may be, a few 100 million that are in dire straits at a given time, but I'm talking about a few 100 million people. So the question is going to be, what's the rest of the world's tolerance for the suffering of significant numbers of people around the world? And that's a moral question that, scientists would have some of the knowledge, but they don't have the moral power, I guess.
Okay, here's another question. The dinosaur mass extinction was just one of 5 biggies, and I assume by biggies we mean big extinction events.
Yeah.
Were the others also accidental or random?
Yeah, I mean, most all this stuff involves tectonics and changes in the Earth's surface. So the biggest one, the end Permian, the transition between the Permian and the Triassic, that's quite clearly caused by massive volcanism from an area called the Siberian Traps, and pouring huge amounts of gases into the atmosphere that really overheated the ocean, overheated land, and it was a bigger extinction than what the asteroid caused. So, as the Earth keeps changing, right? We have this molten core, we have these moving tectonic plates, events happen that change the surface of the Earth. And so that's going to keep happening. One of the other examples I give in the book is, Antarctica 40 million years ago was verdant and the world was essentially ice-free pole to pole. But it was the collision of the Indian subcontinent with Asia in a rather rapid journey north from below the equator that gave us the Himalaya, dropped CO2 levels, and eventually drew us into the ice age. So we live on a very dynamic planet. That's never, well, if that ever changes, we're all going to die. So I should point that out. So we live on a dynamic planet. And as that Earth changes, life is going to change along with it. But the way it changes, I mean, you can just think about, just whatever the picture you want to have in your mind, like lots of billiard balls, moving around the table and ricocheting off each other, and those collisions creating circumstances that have both local and global effects.
Okay, I think we have time for one more question, and it's, if we're the end product of lots of random events, do you think other technological civilizations are common in our galaxy?
Technological civilizations. If you crunch the numbers, there's a chance. But here's the deal. If you visited Earth 12 or 13,000 years ago, you wouldn't have been that impressed, as we all are now, right? Mm-hmm. So it's a very narrow window when you find something you would call technology on Earth. So the idea that life can go on for billions and billions of years and really not have something that we would call technology, we only sent something off the planet, right, in the 1950s. One of my favorite stories is Voyager. We sent something out of the solar system that started in 1977, which is pretty awesome given how short a time we've been doing this stuff. But still, a relatively short window of time. So I'm kind of pessimistic on that point, but the more we discover about the galaxy, maybe the greater the chances become.
Sounds like an
Joe?
ending to me.
Oh, Joe, you got to have an opinion there. Joe, you just got to we got to get Joe to weigh in a second.
Oh yeah, listen, I've seen Star Trek, so I know they're there. I don't know what you're waffling about, Sean.
That's good. That's good enough for me. There's your exhibit A. Yeah.
Okay, good.
Thanks so much to the two of you, both Sean B. Carroll and Joe Palca, and to our audience. Your patronage and dedication enable us to bring you PNP Live's amazing programming, and we wouldn't be able to do so without the book sales to support them. So you can follow the link in the chat to purchase a series of fortunate events, Chance and the Making of the Planet, Life, and You, or you can visit politics-prose.com. While you're there, we encourage you to check out our events calendar for updated listings and the latest and greatest from politics and prose. It's going to be an exciting fall. From one book lover and science truther to another, stay strong, stay safe, and stay well read.